Hi, welcome back to the shop. This is the third episode on the power feeder for the optimum milling machine. In the last episodes we made the parts for the clutch. We made this nice sliding clutch piece and we made the mating motor-sided clutch, and this is how they engage. And here I have the motor where one of the clutch halves will be sitting on, and next to it will be the sliding clutch, so it can disengage. But we need some way of holding it all together and onto the machine, and I decided to fabricate the housing out of this piece of 60 by 60 by 3mm square tubing. And first is to cut it down and machine the ends square, so we have something to work off, because this I cut this with an angle grinder and this is not a really good cut. But better than this end that was cut by the place where I bought it. It's yeah. It's slightly off. I just sawed down a piece of square tubing and now I'm squaring it up on the milling machine. I could run a long end mill over the whole height along it, but that's no fun at all. With a 60mm long end mill, they tend to rattle and shatter, and I don't like it. I'm doing it in 4 steps with a smaller end mill. I'm just turning the piece on. I have a stop on the left side of the vise, so each side gets equally. Okay, let's measure it. I want it to be 85mm and it's 87.23. I just entered the number in the DRO so I know where to go. Yeah. Now, as we machine the first side, we return. We rotate our part by 90 degrees and take another cut on the next side. And hopefully we went up with a nice square tube that has the right length. The end mill I'm using is a 5mm high helix roughing end mill. That's one of those end mills I really like. They run pretty smooth and leave a good finish. Okay, I cut off a piece of flat stock that fits exactly over, and I squared it up so it fits over the end of the of my tubing. We are going to drill and tap it so it fits the bolt pattern of this motor. And we're going to punch a hole in the center so we can mount the where the shaft goes through. Okay, I set up the end plate on the milling vise. I centered it out with the edge finder and the DRO, and now I'm going to punch a hole in the middle with the rotor broach. I need to open up the bore in the center, as I only have an 18mm rotor broach up to 25mm, and as this is absolutely only a clearance hole, no precision needed, I'm using a boring bar. Just a boring bar with a carbide boring tool in it. I'm using that because I can take a heavier cut with it than with my small Wohlhaupt UPA-1 boring head. And we let it run at 300 RPM and feed it by hand. And it helps, of course, if you lock your table in place. Yeah, I'm used to the CNC where you have bolt screws that hold the table in position. On the manual milling machine you have to lock your tables at the table, of course, when you're boring, because the single pointing is moving around the table otherwise. Let's take a quick measurement. 23.2. So we adjust our tool just a little bit. Okay, let's reclamp it. And this is really only for clearance. So for a precision hole you would have to use a dial indicator while you adjust the insert. But I want just a big bore. Table is locked. There we go. There we go. Okay, we adjusted one last time just for a light finishing pass because I can, and we let it run at 580, so we can feed it a bit faster. Okay, and there we go. Making big holes without drill bit. Okay, now we have this motor here and we have this 3-hole pattern, 120 degrees apart, and I want to know the pitch circle diameter of this bolt pattern. There are a few ways to measure this, but you can actually measure from the shaft against this boss, like this, and subtract half the shaft diameter and half this boss diameter, but as these are at different heights, this is a bit yeah, not the best way in my mind. What's easier is to measure the distance between two of these bosses, and that's a nice even number. That's yeah, 55 millimeters, and that's the same on all of these, of course, as this is an even pattern. Here you see it again, 55. So let's sketch this up. We have 3 holes. Here's the center, and we have from here to here we have 55 millimeters. That's to the outside of these bosses. The boss itself has 11 millimeters in diameter, so center to center would be 44 millimeters. That's 55 minus 2 times the radius of these bosses. And now we want to know the circle where these are on. And for that we take out our reference book. That's the standard reference book for metalworking in Europe and especially in Germany. That every apprentice has at least one of these. This is an older edition that I keep in the shop. That's the reason why it's so banged up, but I have it always around. And under triangles there is a formula for the circle that goes around a triangle with equal length sides, and that formula is the diameter is 2/3 multiplied by the square root of 3 multiplied by this length multiplied by 44. So the diameter is 2/3 multiplied by square root of 3 multiplied by 44. So it's a bolt circle diameter of 50.8 millimeters. We're over at the milling machine, and we set the DRO up for pitch circle diameter drilling, or bolt pattern drilling, and we want a circular pattern. Now it asks for the orientation of it. You can drill in the XY plane, in the YZ plane, and in the XZ. The later two are for horizontal milling machines, but we have a vertical machine, so we go for an XY pattern. Enter. Then it asks for the position. Of course, in our case, the center of our pitch circle is 0, 0, so we don't have to change anything. Then it asks for the diameter of the bolt pattern. That's 50.8. Enter. Starting angle 0. That's okay, because we want to start at 0. The end angle That's a bit strange. Normally you would think it goes around one time fully and ends at 0, but it's a bit strange. You have to go, we have a 3-hole pattern, so each hole is 120 degrees apart, and we start at 0, so the 3rd hole is at 240. Number of holes, 3, enter, and now it shows some weird numbers. And now if we crank our table to 0, and it also shows here number 1. Okay, I spot rolled the first position that we just moved to. Now we go back to the DRO and I'll show you how to go to the next hole. Okay, now we press this button and it shows number 2, and it shows again some weird numbers here in X and Y. Now we can crank again over until we have 0, and same in the Y direction. Crank all the way up to 0. Okay, now we're over here. Spot rolling. Back at the DRO and we go for number 3. And it shows that we only have to move the Y direction. And we crank this to 0. I hope you can see this on camera. The contrast in real life is way better than here on this small preview screen of the camera. Okay, this is the 3rd position. Now we move the table out and see if this makes any sense. Okay, just for double checking, I screwed in some pointy set screws into the motor and it fits perfectly. And there is a reason why I like to draw out everything before on paper. What I did do in this case, I just machined this plate up, and as you can see, the lower bolt is very close to the edge, and this plate will be welded onto this, and it fits over these 2 screws perfectly, but of course not on this lower bolt, so crap. Okay, we notched out this lower area and ta-da! Now it fits very nicely over the screw head, and I can even reach in with a standard non-ball and Allen and reach the screw. That's very nice. Okay, I'm about to weld the end cap or the motor plate on. Okay, we have our motor mount here. The motor fits to it. There is space for the screws inside, and Everything comes along nicely, and now we need to cut out a big window here in the top of it. And we need this window for, there will be a plate over it, which the linkage that moves the clutch will be mounted to. So I can remove the whole linkage with the plate that holds on from the top of this housing and adjust it separately. And also I want to be able to get into the housing to lubricate the clutch, to tighten the set screws and so on and so on. There are a whole lot of reasons why you want an opening where you can get in. So next thing is to punch out this big hole on the milling machine. Okay, I roughed out the pocket only paying attention to the layout lines. Now I'm going to do it by DRO to final measurements. Time to pull off the outer bearing for the screw of the table, because we will mount or make an adapter for the motor mount to this plate, and for that we need the plate off the machine. And it's installed in place, but with a soft hammer. And the reason why it's getting off that hard is, look at these dowel pins. They are a bit crooked, just slightly, and that's the reason why this it's a bit hard to pull off. Okay, I machined the mounting plate off camera because it's just milling and boring out a big hole, and boring is of course pretty boring. And I almost messed up. As you can see, this hole is not round. I missed the fact that this piece is not symmetrical, and I centered on it, and that reason that my bore is 0.5 millimeters offset, 1.5. And I corrected for that, and now it looks a bit funny, but this bore is still undersize. This will fit eventually when I bore it open over this hub from the outboard and bearing block. This will slip over it and will get mounted to it. So first I will weld this up. I slotted this piece of structural pipe, and I machined some tabs onto this so everything registers for welding, so I don't have to align it by hand, and I can just drop it in, run a bead all around and go back to the machine. I have it undersized because I want to pick up this this lower bore and then machine the upper in line with it, so both are in line. And also I want to machine this surface flat to this surface. I will run a fly cutter over this. Okay, we're back at the milling machine and I clamped the weldment up to the table, and I have my dial test indicator in there on my holder that's clamped in the spindle of the machine, and I'm centering on the lower bore so I can machine the upper bore and the surface through the lower surface and the bore in there. And I already, this is a bit tricky, I had to use a mirror to read the dial indicator in there. My coax indicator doesn't have a long enough stylus to reach in, so I had to use this setup, and it worked so far pretty good. I will change over to the boring head right now, and then we'll machine out the upper bore. Okay, first pass, and we hit about 50% of the bore. Okay, now he hit about 2/3 of the bore. Okay, now for the finishing pass. This should be the last cut, or at least the second to last. I'm using cutting oil. And also I'm going to increase the speed. No, not. Okay, let's move the table out. And take a measurement. Okay. 50.02 millimeters. Let's see if the flange fits. And yeah, that's good. Oh, that's a nice fit. Okay, that's good. Okay, I just ran a 40mm shell end mill over it to clean up the top surface. I'm pretty happy. There's a little imperfection from the weld, but that's okay. The surface will not be visible later. I mock-up mounted the Powerfeed onto the outboard end of the table, and it seems to come together all pretty nice. The housing, it's still only slipped over this hub. The housing fits very well. The coupling is coupling. It needs a bit of adjustment. The motor is not really in the right position and everything is not tightened down, so this is the disengaged clutch. Now I can hand crank it, and this is the engaged clutch. Now you can't crank the table, but the motor can drive the table. So next thing is to mount the housing to this flange and make a mechanism that shifts the clutch around. And I have a few ideas for that already, but I'm not sure yet what to do. So I think that's it for this episode. Thank you for watching and see you next time.